We'll now begin Module 2, which is our, here we go. We'll now begin Module 2, which is on 3D printing utilizing UHPC. Dr. Aziz Amini will be presenting this section module.
Now, the 3D printing or additive construction or additive manufacturing is a terminology that are used interchangeably. When somebody says layer by layer 3D printing, the first, or somebody says 3D printing, the first thing that comes in your mind with concrete is a layer by layer. But that is not really the case. Okay, I'm going to show you. Now, this is I'm going to show you a couple of. This is one video of this is a printer that is doing a layer by layer. And in fact, we have just purchased one of these 3D printers that is capable of printing a house, actually, if you want to. Basically, this is another one. In a layer by layer, basically reinforcement, manually you have to put the reinforcement between the layers where it's needed, okay? So this is another type of machine, basically the same thing, counter sometimes it's called, okay? Now these are there is a company that actually have provided us two sections, but pretty soon we are going to have our own 3D, basically layer by layer printer that we can print. These are, as you can see, basically this is what it looks like, okay, layer by layer. One of the major problem with a layer by layer 3D printing is the bond between the layers, and that is something that actually that's the reason I came to Munich. There was a 3D concrete or digital 2024. It's called Concrete Digital 2024. It was a 3D concrete printing conference. Okay, one of them. This is just last week. Last Friday, there was a presentation in the plenary section that was done. There was a major study that was conducted. 5,000 experiment was done in many different countries to look at the compressive strength, flexural strength, and the modulus of elasticity of a 3D printed beams, let's say, or structures as compared to the companion cast version. Okay, I took a screenshot. Actually, I'm sharing this. The presentation was made by the Dr. Frick Bose that I have made at the Technical University of Munich, and this is a screenshot from his presentation. So I wanted to give a credit. That's where the information. There are papers that are being published. Okay, and the group is a RILEM. Actually, it's the group that is working is called the International Union of Laboratories and Experts in Construction Material System and Structures. But this abbreviation is really taken from a name in French. I don't know what the name in French is, but it's an abbreviation is RILEM. So this body has done tests. Participating people in this study was many different countries. These are the map of the countries that participated in that study. So this is just one slide. I'm just giving you. This is a ratio of the compressive strength of a 3D printed in parallel to the printed section. Okay, the ratio of the compressive strength of a specimens that were taken. It was core, and then compared to the companion similar specimen but cast in place. Okay, the ratio, as you can see, the line I just draw it here in my screen, 100%. So there are some significant numbers. So and that decrease in that relative strength is mainly because of the bond between the layers. Okay, now what we are doing at FIU is we are using what is called the section printing. Now we are working on another technology that I will tell you toward the end. This right here, this beam that the hollow column that you see is printed, basically using a section printing with the reinforcement in place. Okay, so and we are using, of course, we are using UHPC because of its ductility. We are using it 3D printing really as a tool to achieve what we want. For example, one of the ideas that we have developed is a permanent formworks. So another way, rather than let's say, for example, I want to put a cap beam or a column, rather than building a formwork out of the woods, I can make the formwork out of the UHPC, bring it to the side, put on top of the, let's say, column, put the steel cage, and then fill it up. There are many advantages to this permanent formwork using a UHPC. Okay, you can put a lightweight concrete inside, because remember, rapid chloride permeability numbers is very low for the UHPC. So what's inside is going to be protected probably for life. And even that small thickness of a UHPC shell that you provide adds quite significantly to the strength of the element. That allows you to make the section smaller. Section gets smaller, the total dead weight gets smaller, the total your foundation size gets smaller, so it's lots of saving. And this has been done. I mean, a formwork out of a, let's say, normal concrete has been done in the past. So what we are doing basically is using a UHPC. Okay, this is a cast in place actually. This cap beam that you see is a cast in place, but we've also printed. I'll show you. So the whole idea with this permanent formwork is that you can print a cap beam or a shell for the rectangular column or round column, bring it to the side, and then we do have a connection. I don't have it in this presentation. Stack them on top of each other after putting the reinforcement, then fill it. Okay. This is a, for example, this beam that you see here, we have printed. This is kind of printer that we have used. This was a very early one. Okay, very early work that we were doing. Basically, some people call it a slip forming, which is fine. I say really 3D. When you say 3D printing, you should not equate that with a layer by layer. I look at it as an automation in the construction. Automation could be any different type. It could be section printing, could be one combination that I'm going to show you at the end, or section printing. We've actually, for this beam, we did basically constructed just a rectangular beam. Okay, we had the shell printed. We used the section printing, and then we also had the shell using the cast in place. We wanted to see what's the difference between all of them, and all of them were made had the same amount of reinforcement, same cross section. Okay, and now one thing you can find in the case when you put the basically, especially in a flexure intention zone, UHPC, let's say you have a beam that's subjected to a, let's say, flexural type loading moment, you get a distributed cracking. At some point, one of the cracks at the location of the maximum moment, basically, at that point, the steel fibers pulls out, and the localization basically take place. At that point, basically, this is a point that I'm pretty sure Ben is going to discuss that a little more. That's a point that from that point on, one crack basically becomes the dominant, and then the rest of the cracks, they don't get wider, but that one particular crack start getting wider. And the same thing basically happens in this case. Now, I will make this comment. If you don't want to have basically a localization of the crack at one location, we've done some tests. You almost have to have a mechanical action between the shell and the what you cast in. If you do that, then you do get basically the other cracks too, because you get a very good composite action between between the normal strength concrete that's inside and the UHPC shell, and you tend to all the cracks to get wider. But in the case of the shell, if you don't have that, basically one crack takes over, and that becomes a wider and wider, and then that's the end of the game. Let me show you just picture. This is a concrete beam. This is the cast in place UHPC. This is the 3D. You can see over here, actually, the shell, there was a slippage at the very high displacement level. There is a slippage. And this is another view of it. Okay. And this is the, let me just get the pointer. So the concrete beam, it's this line right here, okay? That one right there is a concrete beam. Basically, that was tested, the load deflection curve. The conventional one, the UHPC shell, using just a cast in it, is that blue line, and then the 3D printing ones, 3D printed one is this right here. So we do see some, even with section printing, a little bit lower stiffness and then lower capacity, but it works fairly nicely. Now, let me show you some other examples of the section printing that we've done. So in this case, the idea is that to print, let's say several elements like that, okay, put them side by side, then put the steel cage and then fill it up, okay, with the concrete. The sections, this is the type of the connection that we have. It's this connection, the way it works, as you put more weight over here, it is basically, it forces this element to press against each other's. Let me show you here. Basically, the element, there is no physical connection. There is no mechanical connection or bolting or anything like that. It's just the two elements that you print are pressed against each other once you put the basically, you feel the formworks. So again, let me go back here. So the idea is that if I have a short span bridge, I print these elements, okay, and then put them side by side, and then put the steel cage, fill it with the concrete. So we've done some testing on this. This is each section this is a schematic of how it works. Now, so far we've been basically manually feeding the UHPC, but we are automating that process, which is not that difficult. These nozzles that you see we made, basically it's a homemade. I'll show you the ones that we've made. So our printer basically for a section printing is just you can have any kind of nozzle. You can print any section that you want. In fact, any size that you want. So this is not a layer by layer. And the advantage is that you can put the reinforcement you can pass it through the nozzle. So the section that you print, it can have already the reinforcement in it. Whereas in the case of the layer by layer, if you remember, we had to basically manually put the reinforcement in. So here is a time lapse. Again, in this case, the UHPC was fed manually, but we are trying to automate that process. Okay. So here is a printing one sections. Now, if this moves continuously, this is one of the experiments that we did some months ago, but more than a year ago. One of the PhD students, Fahim, who works for one of the consultants nowadays in the Miami area, was working on this. So it can be fairly smooth. You can have the reinforcement. I believe this one was maybe around 20 feet, I believe, or so. And then after that, we put the reinforcement. We filled it with the concrete, and then did the flexural test. Even in this case, the shell, basically, we did have a localization of the cracking, and then one cracks dominated. It showed a fairly nice behavior and capacity. Okay, so here is the different sequence, printing, put them side by side, put the steel inside, and then fill it with the concrete, basically. And these are the photos of the testing. We've had another one. We had a project with NASA actually to construct habitable structures on the moon using the local materials. So we used a special material for this particular case. But the printer was basically printing blocks. Okay, I don't have the photos of the plot, but in this case, I mean the nozzle. And let me just maybe this one is a good one to show you how the nozzle works. The nozzle is basically the head, whether it is any section, the hollow column or formwork for shortest span or the blocking. It's a two ring and it's got the heat elements inside. And then that cavity allows you to pass a reinforcement and you can make any kind of nozzle shape basically. And the movement and the UHPC is deposited between this basically. That's why some people calls it slip forming, which is fine. But it's the automation of the process. Okay, this is a printer. Basically, this platform that you see here goes from the top and then moves down. Here's a schematically showing this. So as it moves down, basically, you are depositing the UHPC from the top and then print. So this one is a printing a hollow column. Okay, and here is the printed. I think it's a 14-inch by 14-inch hollow UHPC column, and this is the cast-in-place version of it. Okay. Again, the advantage is that you can put the reinforcement because the nozzle allows to put the reinforcement. This one actually had the stirrups. Basically transfers reinforcement for the column and longitudinal reinforcement, and this extension is so that you can use that to connect it to the ground. Here's another photo of it. This is a printed one, the 3D printed hollow column. This is a cast in place one. These are cast in place. This is a hollow column. And then we took it basically, and then we embedded the columns in the foundation basically, and then subjected the specimen to the constant axial load and a cyclic lateral load, as you see over here. This is a load deflection. This one is the printed one. It's a little bit lower stiffness and lower capacity. This is just a one test. I wouldn't hang my hat on this one, but nevertheless, this is the results that we got. It provided adequate ductility, and but nevertheless, it had a lower capacity. This was actually because of the connection to the foundation. It wasn't the section itself. There was an issue with the connection that we used, and the failure was kind of localized at the foundation level. But nevertheless, that's the capacity. Now, finally, I'm going to show you this one, and then we'll open it to a question and answer. The next generation of the 3D printing that we are working, we are combining the layer by layer and the shotcrete with the UHPC. The advantage of the layer by layer is that it can be fast. You can print the layers by fairly fast. The advantage of the shotcrete is that, of course, we can do the UHPC in the previous presentation you saw. So now we are combining the two technology together. I think this will solve the issue of the bond between the layer by layer. The bond between the layer by layer is here with us to stand. I saw actually last week in the conference there were presentation that they were looking at some kind of admixture to increase the bond. some other alternative, but I think that that problem is going to exist. It's adequate, layer by layer is adequate for residential housing, for example, let's say, where you don't have very large load. But if you want a load bearing or a structure that's going to be subjected to heavy load or cyclic loading or things like that, you got to solve that layer by layer, the bond between the layers. And I think the combining the layer by layer with the shotcrete with the UHPC can achieve that goal. So, but anyway, if you are interested, we in this kind of work, I think the precasters, really the precast industry can take advantage of this kind of a section printing. You can print almost many things with this kind of approach. So, Kathy, that ends my presentation. I think we've got maybe about 10 minutes for the question and answer. I wanted to leave some time for question and answer.
Okay, Torrid, this is Paul, and we'll get on into the question and answers. First one we have here is you mentioned issues with bonding between the printed layers. That's in your layer to layer thing. Is any surface preparation required between the layers?
No, it's a layer by layer. Basically, when you print it, you just go one layer and then the second layer on top of that. No.
Okay. All right. And second one was, please comment on the development of 3D printers and their potential for future commercial availability.
Yeah, these printers that you saw, the ones that we have, basically we build everything ourselves. We don't buy anything. It's just in fact, we even buy all the wires and everything assemble. You can build anything you want. We found out that in order to have the nozzle to move at certain acceptable speed, you have to heat the material, heat it up to 125 degrees Fahrenheit. And that has proven not to adversely affect the short-term effect. We don't know, I don't believe it has a long-term effect. We haven't studied the long-term effect of it, but at least the short-term or within 28 days, the F prime C and so on was not affected. So what those printers are, we have basically been building it in the at FIU ourselves, but I'm not sure. There's no company. I mean that's at this point.
Okay. How do you manage you're talking about the nozzles, but how do you manage the steel fiber component of the UHPC mix? Is there the potential for the nozzle to jam?
Yeah, in our case, of course, that's an advantage of our case because between the two rings, there's a space that you pour the material. But layer by layer, you use there are different ways that sometimes, basically, you pump the concrete to the nozzle, and the UHPC, I mean, the fiber can have the same issues that we have with concrete when you're the pumping. But in our case, we don't have any issue because the cavity, between the two rings, we have enough cavity that you can pour without any problems.
Okay. The 3D printing of a concrete shell for interior concrete placement is innovative, but can the shell appearance be improved for can the shell appearance be improved for aesthetic considerations?
Yeah, I think so. I think we get to the point that we can feed the material that we need, and the nozzle moves at a constant speed. Then you will get the completely smooth surface. The reason that right now we have a little bit of styration because we were feeding the material by hand, and also we had to wait a little bit before we go to the next one. And that's one of the reasons that you see it seems like there is the sections to it. But if you can move smoothly with a section printer, you won't have that. But with a layer by layer, you're always going to have that.
Okay. Maybe you had mentioned previously the poor adhesion between dried UHPC and fresh UHPC. How is the phenomena avoided when, for instance, the beam shell and the UHPC that's poured into the shell?
up to very maximum load capacity, you do get frictions, and if you put some deformations in the shell, you do get up to about the high maximum capacity. You do get pretty good connection, but at some point it breaks off. So with the shell, with the ultimate, I think you can achieve the ultimate strength of the shortest span bridge, but ultimately something is going to have to fail. In that case, you're going to get separation.
Okay, go on.
The test that we did on that 20-foot long, we did get a fairly good behavior, but at the very end, we did have a separations. We did have a separation between the shell and the normal strength concrete.
Okay. How is the mechanical linkage achieved between the precast shell and the fresh UHPC fill material?
If you have a hardened UHPC and you want to cast a normal strength and you want to get a complete composite action, the only thing is that physically to have some something inserts basically in the UHPC shell that's hardened. That's the only way to get it all the way to the end. Other than that, no. You cannot rely on a fresh normal strength concrete or fresh UHPC cast against the hardened UHPC.
Okay. All right. I'm going to go ahead, and we just have a few minutes left. I'm going to turn it over to Rick. I see we have a couple more questions that have come in. And Rick, you want to come in?
Yep. Thanks, Paul. So how was these units cured? You know, obviously we moist cure, do different kind of curing processes and these elements.
Yeah, the ones actually we had in lab, we did not cure it. We just printed and then let it sit in the lab. We didn't have any curing compounds or anything, and we didn't see any cracking or anything really. But it was in the lab condition with temperatures constant, you know.
Yeah. So how much time these different, obviously you had several different elements or different units that you worked on there. What kind of timeline did it take to perform it?
That's a good question. Let me just show you I had one slide that it's not a short time. Here it is. This column that you see, 14-inch by 14-inch, 2-inch thick shell. Heating, we went to 125 degrees Fahrenheit. Printing height was 66 inches. Total time was 6 hours and 15 minutes.
15 minutes. And that's a continuous thing, right? Erod, I mean, you
don't. It is, yeah, right now it's not fully automated, you know, because we had to stop and go. But we are trying to have the mix. It's a simpler problem to solve. We are trying to have the mix basically prepared exact amount that you want, and then see what we can do in order to move a little bit faster but continuously. Mm-hmm. Because if you move continuously, then you won't see these like it appears in the cold joint. But right now it's taking time. I mean, it's not fast process. Layer by layer. That's why the layer by layer. The advantage is that it's fast. Disadvantage is that you cannot put the reinforcement inside. But if you combine it with the shotcrete basically kind of sews the different layers together. Okay, so we are looking at the basically shotcrete at the nozzle level, not shotcrete after it's hardened.
So when you printed those out, like that column there, basically, did you print from the top to the bottom or from the bottom to the top?
No, here is actually, you can see, let me see. Do you see how it goes from the top? Platform goes to the top, and then the nozzle allows to put the reinforcement, and then you just know. So
what was the advantage, do you think, out of doing that one versus the other direction?
This one, actually, the gravity helps. The gravity helps for the concrete to get consolidated, you know. and that we found out that that's very helpful. So if I come from the top, and it was more stable. We did the other way too. Actually, we had another printer that was going from the bottom up, but the top to the bottom was very nice.